Okay, so again, the notes for the first 6 problems are in the first video, so if any of you want to go back at any time and watch the videos because you've forgotten something, I put the first 6 problems in the first video, and then I'm going to put a few in this one today, and then we'll make another video for the last 6. So the clock pendulum problem, we kind of looked at this already before, but this one's just going to twist it slightly. So if it swings back and forth once every 2 seconds, then it swings out for 1 second, right? Okay. And if its length is 1 meter, the greatest angle that it can move from the vertical is 12, meaning that it can move, see, this is the vertical, right? It can move 12 this way, or it can move 12 this way. And that whole thing is 1 swing. So 24 degrees is 1 swing. Does everybody understand? All right. It says, how many kilometers does the bottom end of the pendulum travel in 1 day? So this is going to help a lot of you who maybe had trouble last night with some of the conversion factors. I think there was at least one question, maybe more, that asked you to change it from maybe centimeters to meters or seconds to minutes, or they made you change the units, and maybe you weren't familiar with that process. Well, this problem is going to help reinforce how to change units.
Would you consider the back and forth one revolution?
No, not exactly, but kind of on that thought process. What we've got to do is figure out how long one arc is, because that'd kind of be like one movement's kind of like one revolution. So this one's more related to arc length, but the same kind of concepts that we do with the units on converting can be used with angular speed. All right, so we're going to actually work on arc length with this one because it doesn't go all the way around. It's only how far is this distance for 1 swing, not back and forth, just for 1 swing. Because if it does back and forth in 2 seconds, then it does 1 swing in a second. If we can figure out how long 1 second is, sure, we can figure out how many seconds are in a day, right? All right. No.
86,400.
All right, so we're going to do arc length. How many degrees was my arc? 24. Why is it 24? Because the pendulum starts over here and has to go all the way over there for 1 swing. Times 2 times pi, what's R?
1 meter.
1 meter. All right, so first we've got to figure out that and get this answer, and that'll be just what the length 1 swing is. So I suggest don't put the pi in it right now. Just multiply the stuff in front of pi, and let's keep the pi with it for just a little while, and then we'll multiply the pi at the end like we do when we do angular speed. So 24 times 2 divided by 360, math frac, would be a good idea.
2 over 15.
Everybody agree? 2 over 15 pi meters. All right, so that's how many meters it moved. Now, that's in 1 second. Everybody agree? So my velocity is 2/15 pi meters every second, because this is the length of the arc in 1 second. 1 swing, that's its length, so that's how much it did in 1 second. So we can just convert that to a velocity and say it's over 1 second. Now here's where your unit conversions come in. And I want to go through this one kind of slowly, so pretend you don't know how many seconds are in a day, because next time you might have to do it for minutes or hours. All right, how many seconds are in a minute?
60.
So I put 60 on top over 1 minute, because won't that make the seconds drop out? Now I got it in minutes. Am I going to stop? No. How many minutes are in an hour? 60. Now I got it converted to hours. See, my seconds have dropped out and my minutes have dropped out. So I've got it to hours now. But I asked for a day. So what conversion factor do I need next? 24 hours. So I put 24 on top because I want the hours to cancel out, and that'll turn it to a day. Now my hours are gone. Whoop, I didn't mean to mark the 24 out. I just meant to mark the hours out. Now, I got the day part in my problem now, but I don't have the kilometer part in my problem now. So now I need to figure out what that conversion factor is that I need, because I got to convert meters to kilometers. And I'm not going to do it with the just move the decimal thought. How many is it? 1,000. Now, 1,000 meters is in a kilometer because it goes on this side of meters, it's decimilla, right? And when you go the other way, it's deca, kilo. Okay. So it's 1 kilometer is 1,000 meters. So I put meters on the bottom because meters on the top over here. So that the meters on top and bottom will cancel, giving me kilometers over a day when I get done multiplying the whole top and divide by everything on bottom.
What is it? How many kilometers? Does that say 12?
1 kilometers.
What does that say?
1 kilometer over 1,000 meters. It just ran into my 12 over here. Let me erase my angle junk here. It's just 1 kilometer. Green sure doesn't show up very well, does it? I'll try to stick with red and blue. They do better. It's 1 kilometer over 1,000 meters. So here's what we've got to do. We've got to multiply everything on top and divide it by 15 and divide by 1,000 because that's the only two numbers on the bottom. So we're going to say 2 times pi times 60 times 60 times 24. And that's everything on top, right? And then we're going to say divided by 15 and divided by 1,000. And that will tell me how many kilometers per day it moved.
I got 36. I got 36 points.
Everybody agreeing it's 36.19 kilometers a day? Now that's velocity, right? All right. Did you divide by 15 and divide by 1,000? And not times them two together, right?
No, because when you times those two together like me, you get like 4 million.
Because you would have to put parentheses around the bottom if you want to go 15 times 1,000. Yeah, let's check it. 2 times pi. Did you put the pi in there with the pi button? Times 60 times 60 times 24. Hit enter. Now hit the divide button. 15. Divide button. 1,000. Let's do it in pieces and see if that helps.
That's what I got. 16.
Now you're getting 36.19?
I got it.
Just try to use
Yeah. Yeah, when you hit enter and hit divide, it puts the word answer on your calculator. Like I had here. It puts the word answer on your calculator. Yeah. So that means take that answer and plug it in.
Hey, Kelly, look at her now.
Okay. All right. So is that what the question asked for? Did they ask me for velocity?
No.
No, they asked me for the distance it traveled in kilometers, so I dropped the word day and say it's that many kilometers for the distance D equals. Because I'm really looking for the distance, not the speed. And if it's for 1 day, 1 times that is the same thing, it's just day would drop out, right? Yes. Okay, we have 2 more questions to go. Okay, circular saw speed. The circular blade on a saw has a diameter of 7.5. What did my brain telling me?
Diameter, you divide it 0.2 though.
Alright, so what's my radius?
3.25.
3.25, I lied.
3.25?
3.75.
7.5. Okay. So we need to make sure we divide it on the calculator, don't we? Just make sure. Alright. Here's a thought. What's half of 7? What's half of a half? Half of a half is a fourth, and what is the decimal for a fourth? So 3.5 and 2.25 come out to 3.75. Just have two pieces and add them together. Alright, omega equals, what am I writing down to get radians per second? It's what I'm looking for, but what do I start with? Revolutions per minute happens to be 2,400 revolutions every minute. Well, I got some issues here. They want radians per second, and I'm in minutes, but we'll deal with that in a minute. Let's get the problem set up first. So first, I'm supposed to put 2 pi radians over 1 revolution because we want the revolutions to cancel. Does everybody understand what I'm talking about so far? It's the same thing. But when I get to that point, I've got radians over minutes, and it didn't ask for radians over minutes. It wants radians per second. So this is those conversion factors again. How many seconds are in a minute? Does the 60 go on top or bottom this time so my minutes will cancel out? It goes on the bottom because I want to put 1 minute on the top so it will cancel with the other one. So that's how you decide where to put them. Is you look for which one you want to cancel and you write the other part of it so it's not going to cancel. And then obviously I needed seconds on bottom because it says per second, and seconds has to be on bottom for it to be per, right? Alright, so now we're going to do 2,400 times 2 divided by 60 to put it back on my pi because pi has to be a number in front of it for all these numbers being multiplied and divided. 80 pi? Okay, 80 pi radians per second because that's the only units I have left. Now, the speed of the saw teeth in feet per second as they contact the wood being cut. So when you start your circular saw at the edge of the wood back here, the speed at which it's traveling before it hits the wood, because we know once it hits it's going to kind of slow it down because of friction, right? But right before it hits the wood, we want to know how fast the blade is turning in feet per second. Now, this is in inches, so somewhere along the way we obviously need to convert to feet, but at least this is in seconds, so the time unit will be correct. So we'll set up the problem for the velocity, and then we'll put the conversion factor on there as well. So, velocity equals the answer we just got for omega over seconds. And now we're ready to fill in our radius over 1 radian. So we're going to put this 3.75 inches over 1 radian because we want the radians to cancel out. And now I have inches and seconds, but I need feet and seconds, and I don't have feet. 12 inches in a foot. Does the 12 need to be on the top or the bottom? The bottom. So 1 foot is going to be on top because we want feet to be on top to be feet per second. So the 12 inches has to go on the bottom for the inches to cancel. And we're going to do 80 times pi times 3.75 divided by 12 because 12 is the only number on the bottom. And that's going to come out in feet per second because those are the only units I have. Everybody agree with that? 78.54? That number sounds familiar. I think we got that on another word problem yesterday. All right, so that's why it's important to set up your velocity formula first and then look at, are my units right? And if they're not right, put your conversion factors over here on the end so that when you multiply it all together, you've already got it in the correct units. Now, the other thing you could do is you could get the velocity answer and then in a separate step do the conversions. And there's nothing wrong with that. You can do it that way. I just like doing it all at once so I can type it all in the calculator.
I definitely saw was rolling.
Oh, yeah.
If it goes 78 feet in a second,
Oh my God.
which is why you don't want to put your arm in front of it. Or any fingers. Alright, our last one for today is number 9.
Bless you, Chris.
Yeah. This is a real Ferris wheel. It's not a made-up question. Okay? Some of these questions may be about real objects, but they're just made up. But this one's real. This is a famous Ferris wheel from Texas that was in their state fair called the Texas Star. It has 60 feet diameter.
30 feet.
Okay? Radius is equal to 30 feet. Now, if you think about that, a yardstick is 3 feet, right? So it would take 10 yardsticks to make just the radius. It would take 60 yardsticks to make the diameter. So this thing is huge. So did I say that wrong?
60 yards.
6 yardsticks is what I meant to say. No,
20.
20, I mean yardsticks, because it takes, you got the idea. I can't talk today. But it says it makes 1 revolution every 3 minutes. So this one's even slower than the Ferris wheel we had on the first time, right?
Probably because it's huge.
Exactly, it's huge. And think about it. If it's 60 feet across and the people are getting on down here at the bottom are a little bit off the ground, right? That's way up there.
I would be so happy.
But what I find interesting about this question is part A says find speed, which means velocity, and part B says find angular speed, which means omega, and they're thinking somehow you're going to magically figure out how to do velocity if you don't have omega.
They put it first. You gotta do a speed first.
Well, I would, because we understand that method a lot better, don't we? There is a way to start and get velocity, but it's not easy. It's kind of real complicated. Yeah, it's a little complicated, and if you do them all in the same direction all the time, it's just easier. So if they give you the radius and they give you the revolutions, then when you read the question, just go do the angular part first, no matter what they tell you. So we're going to say 1 revolution is every 3 minutes for that 2 pi radians over 1 revolution. So basically, this turns 2 pi over 3 of a circle. If you think of it like what we talk about with the unit circle, you know what I'm talking about? If 0 is down here, it turned to there in 1 minute. Does that make sense?
And you put the other side and make a pretty cool part.
Mm-hmm. All right. Now, that is our angular speed, so we're going to come back and do our velocity now. Velocity is equal to that angular speed times what? 30 feet over 1 radian, so that the radians cancel out. And guess what? You can reduce some other things if you'd like in this question. 3 goes to 30 10 times. 10 times 2 is 20. You could do some of that math by hand if you want to, or you don't. You can type it all in the calculator if you want to. But I like looking at the fact that those are small numbers and I can do them in my head, so I only have to type 20 times pi. You may decide, well, I'd just rather type 2 times pi times 30 divided by 3. And if that's what you want to do, that's fine. Doesn't hurt to try some fraction skills, though, once in a while. So this is in feet per minute.
62.83.
What?
62.83.
Now, yesterday we talked about just turning something into miles per hour for fun because it was kind of interesting. So this one would be even slower than the one we had yesterday. It was like 0.8 when it was like 40 or 20 feet. Can't remember if it was 20 feet radius, I believe.
That's ridiculous, though, because that thing is so slow.
Oh, yeah.
You want like 2 feet a second.
Yeah, you're not going very fast. So pretty much you get a nice, slow, leisurely ride, and you can look out along and see all the scenery you want to see.
And then they start unloading and you have to sit at the top.
Forever.
That's the best part. No,
I'd much rather ride than wait to get off. All right, so now in your packet for homework, when you look at your homework packet, let's see how many questions you now will be able to do. Can I borrow yours? So I left mine at home for my husband to type it. So I want to type this up. Got to be careful.
You should go to the west of Atlanta. 84 stories.
Okay, you can go to number 10 now.
That's right. It's speeding. Awful, actually.
You will now be able to go through number 10. You will be able to get to number 10, I believe, with no problem whatsoever. If you run across one that, as you go through, gives you, instead of revolutions or radians, they give you something like miles per hour or feet per second in the question, you might want to skip it. We haven't studied that yet. We haven't studied how can I give you angular speed and go backwards, but I think up through 10 doesn't do that. So you should be able to finish through 10. If you get stuck on one, just stop and skip it and come back to it later.
Are you gonna go?